Okay, so we got a question right here. Point charge of positive q and negative q are placed at x and y respectively. When another charge is placed at z, the resultant force on the charge at x is 0. Distance x, y and equals to distance yz. Which of the following is the charge placed at z? So let's highlight the important points. We have two charges, right? They are placed at x and y. We can see it in the diagram, right? We have another charge it is at z, and because of that charge our x charge is getting the resultant force as 0, right? So and we have distance basically equal, right? So these distance are basically equal. So before our force was going right here because they were attracting, because they are opposite charges, right? And then once this thing came in, this charge came in, now it's basically having 0, right? This was f1, this is f2. Basically they have zero. So that means because it has a 0, so means they are both equal, right? So the amount of force that is making it to repel from here to point till here, like midway here somewhere, these two will be the same force for its repulsion, right? So we can just safely say it as f1 is basically negative of f2 because it was going I took the positive direction right here. The motion is positive from here, right? So we can basically say it for easier understanding, right? So f1 is going here. We are saying that it is going on the negative direction, so we say this is negative, right? And now we have to write the Coulomb's law, which is the formula of it is q1 q2 and then it's multiplied by the k constant, and then basically we have r square, right? So let's substitute it here. So we have f1, we have q1 as positive q, we have q2 as negative q because it was before and then it gets after, right? So before it was this, and then once these two charges came it becomes basically 0, right? So we're gonna put the k here, we're gonna put r square here, right? The distances are means they have the same distance, right? So now we need this, right? This charge and this charge. So we have positive q right here, and this is basically negative. The whole equation is negative, right? And then we're gonna write this q because we don't know what this q is. We're gonna write this as k. We're gonna do it as r plus r is basically 2r, so it's 2r square because we are measuring from here to here, right? Because from here to here the force is happening for it to become equal, right? So we're gonna put it right here, and then we can safely cancel out these two negative, this q, this q, this k, and yeah, okay. And then I forgot to put the brackets, it's like the whole square, okay? Don't forget that. So now we can basically write this as q equals to q r square, and this is 4r square, sorry, 4r square, right? So we can cancel out these two as well. So now we have q is equals to q by 4, and then this goes up here, and then we have q is equals to 4q, right? So T is our correct option. We need 4, like 4 times the charge for making this charge basically have a resultant for 0, basically just making these two charge equal, these two forces equal for this resultant force to be 0, right?